this is a video just on how we expect you to be displaying and formatting your tables and your calculations for lab reports for grade 11 physics and sort of scoring well on your diploma. So the first thing is I'm just going to use a simple time against temperature sort of set of data for you for this example. So the first thing is every time we have a data table, we always want to make sure we've given it a little name. So usually kind of just have it in italics at the front. We can call it like table 1, and this would be raw and processed data of time and temperature. And you can sort of leave that on the top. You could put it on the bottom, but we usually do give a little kind of explanation of what our table is. Sometimes we have more than one data table. So in this case, I was looking at the time, and again, sometimes we want to specify what that time is. In this case, it was the time of heating, and the time of heating would be measured in seconds. So I'm going to put my unit of measurement in brackets. Sometimes people could also put it with a little dash, whichever one you prefer. I'm going to just use the brackets for mine. Now, the other thing we always want to have in our heading, as well as like a specific name on our unit, is we also want the uncertainty. So in this case, my time was one for my stopwatch, and I could measure to 2 decimal places. So I'm going to just put in the plus or minus sign. Again, find that where that is on your keyboard, or you can always go to insert special characters. The plus or minus 0.01 seconds. Okay, so again, you can have it all in one line. You could put it on below. Doesn't really matter. Now, because this is measured to 2 decimal places, what I need to do is keep my precision of my data in my table also the same. So this would actually be 0.00. This should be 30.00, 60.00. And again, just keeping that level of precision constant. And like so. So again, we then come on to temperature. We're going to do the same thing. We're going to talk about temperature of what? So the temperature of the, let's say, the copper block, and that was measured in degrees Celsius. So I'm going to just have, sorry, I pressed the wrong button there. We're just going to have, let's just go, there we go, degrees Celsius. And again, the uncertainty for this was our smallest measurement. In this case, we could measure to the nearest Celsius. So I was saying plus or minus 1 degree Celsius. And again, you can either put that next to it or behind, but again, just wanted to keep those in. And you might want to format just to kind of keep your tables a little bit neater, to keep the uncertainty at the bottom. What I've then put in here is the temperature in Kelvin. So again, temperature of the copper block. And again, this case, I'm just going to put Kelvin as my unit. And again, plus or minus 1 Kelvin. Sorry, I just made a little mistake there. That should have been 0.5 degrees, because we can measure in there as Celsius and it's analog. So we could use 0.5. In this case, because it's 0.5, what I'm going to do is place in, this becomes 21.0, this becomes 25.0, 31.0, 33.0, again, same here, 0.0, 0.0, and 0.0. Now, I should just quickly specify, I used a thermometer that I had to read from. If we read from the equipment, it's half of the smallest measurement, but if it's digital, then it's just the smallest measurement. So just be really careful. If you use the digital thermometer, then it would be your smallest measurement that you would put down. Now, what we've also got with kind of this experiment of specific heat capacity, looking at time and temperatures, we also had some constant values that we needed to look at. So there's a few different ways that people like to display them. Sometimes people put them as a complete column. Sometimes people write them below, like they might say the mass was 1 kilogram, and they just put it underneath the table. I've also had students in the past actually just make a column to the right and then just merge it. And have had students write things like mass of the block and then put them in like here, current was, and then put it in, like again, current should be measured in amps, or you could just write equals and then let's say, I don't know, that was 0.6 amps. So I've had people do them in different ways, but you do need to make sure you've got your constants somewhere. So whether you put it in as a separate column whether you just write them underneath. If you've measured the current each time, then you would have it as a column here as well, or maybe over here. But putting a constant in, or making sure you don't ignore your constants, that they are written somewhere in your lab report, is useful, okay? And again, uncertainties, we usually put uncertainties in the heading unless it's one where we've done multiple trials. So let's say you recorded the temperature 3 different times. You may do the temperature, so we could say like absolute uncertainty of temperature. And what we could do here is, and again, you can just use the symbol for this, we could put in for like the range over 2. So sometimes if we've got many trials, so if there's many trials, then we would do the range over 2 for them. And that would always be then as a separate column because each one is going to be a different value. So just a little few things there on kind of formatting your table at least. So always make sure you've got a clear heading, got your unit, got your uncertainty, and you've checked that your precision of your data matches your the rest of the column and also matches your uncertainty on the top. They don't have to match everything else. So for example, the time was 2 decimal places. This was only 1 decimal place. So that doesn't matter, but all of these being to 1 decimal place does matter. Okay, so that's one little thing that we do here. The other thing then is that when we've done any sort of processing, so let's say I had to calculate a range over 2, let's say I had to calculate a mean, I had to calculate, in this case, temperature into Kelvin, we always want to make sure we show one example of those calculations. And so usually we put the calculation just underneath the table of what we've had to process. And I like to use the equation function here. So I like to go to insert, go to equation, and I'm just going to write temperature in Kelvin. And temperature in Kelvin was, we did the temperature in Celsius plus 273. And in this case, let's just do 21.0 plus 273 equals 294.0 Kelvin. Again, that's just like a nice little simple one there, which is just kind of using the same formatting, so all my calculations would be the same. But let's say later on, when you had to calculate, let's say, the gradient, I might go again, new equation, and we could say the gradient is equal, I'm going to use the operator for the decimals, and I'm going to say the V and I over M and C. Again, you can either use the symbols or you can use the words. And in this case, maybe I'll put in some values. I'll put in what the gradient was and then put in my values and then rearrange for C. But it's just a nice way to kind of format out your calculations there. Now, if I'm talking about the gradient and do my calculations, I'm probably not going to put that calculation here. I would put that under the graph. Okay, so also where to put your equations or calculations is also really important because it helps with the flow of the essay. So any calculations for the tables go with the tables. Any calculations for the graph, they go with the graph. All right, so we see the data first, then see the calculation. And again, using this, we usually show it first of all in letters or words, and then we then show one example with a calculation. You don't need to do every single one. I only needed to show the first one, and that's all I needed to do for this. Okay, any questions, please let us know.